I was asked to do a short talk to try and describe what managed track position is, and the thing is I have appreciation that there's probably people in this room who are possibly new to the industry. So I've tried to describe it in a way just to start from, I suppose, basics, describing the sort of basic concept, but this is no way to sort of undermine the survey and design skills that are often behind the process. So what is managed track position? Well, managed track position is a defined track alignment that can be reinstated when the track is disturbed by track maintenance or track renewals. And the good news is we have a standard, TRK 3417, which helps to specify the requirements. Within the standard, you'll find there's various levels of MTP. There's sort of level 0, where we just look at retaining the design and survey control for future use. There's level 1, where maintenance may choose to use that information for realigning the track, but not for their entire route, but for sort of key locations, which may be higher risk. And there's level 2, which is the more complex locations where maintenance would use the information for realigning their track for their entire route. And this is more aligned to absolute track geometry, ATG, for anyone that's familiar with that. So those are like the 3 levels, and you'll find that within the standard. There's also within the standard an example just to briefly illustrate what the level 0 to 2 are. As you can see there, I won't read through them all, but sort of level 0 being a piece of plain line track, straight track, middle of nowhere. Sort of level 1, one of the lowest speed category track, which may need tamping maybe every second or third tamp to the design. And level 2, as I said, more aligned to if you've got areas of high count deficiency or complex layouts, in which case you want to maintain that track to its design position all the time. And for some people new to the industry may be surprised to hear that we don't actually realign our track generally back to its design position after we've done all that good work during the renewal process. So the MTP philosophy is basically, it's like a recycle. It's looking at reusing existing survey control, Form B, and designs. So once we've done all that good work as part of the project in creating the renewals, design information, then we can reuse that for track maintenance and also future renewals. And that's the philosophy behind it. Well, what are the benefits? Well, there are safety benefits, of course. Reduced risk of train collision due to failing passing clearances, or losing track position from creep. This is where we repeatedly maintain the track to an uncontrolled position, and over time we can actually lose the design position of the track. And of course, to reduce the risk of dewirement caused by track misalignment. There's also some design benefits. There's been some recent changes to TRK 2102, which now allows certain maximum design values where MTP can be provided as an additional control. So areas where it might be looking for possible line speed improvements, they can actually look by adopting MTP, they can enable them to do this going forward. So where do we start? The survey strategy, to me, is what's key to managed track position. Having an established survey grid in place is what's key to the foundation of managed track position going forward. And again, the good news is this is already in the standard. This is actually something we should already be doing. It's nothing new. TRK 3100 describes what the strategy should be at early grip 2 stage, during the early concept stage. So you should have survey teams going out, seeing what the survey condition of the survey control is. Because one of the issues we have within Network Rail, we don't really tend to manage our survey grids. And so we rely on the track renewals when they're going out to do their works to have some kind of survey strategy to understand what, if any, of the survey control need to be retraversed or replaced. Again, for some of those who are maybe new to the industry, I thought I'd just put a slide just to describe what some of the terminology are for survey control. So we've got PGMs, which are permanent ground markers. You might see these in the base of the signals, in the concrete base. And these are our secondary control, which are coordinated. So there's an X, Y, and Z coordinate to them. We've also got TMGs, which are track machine guidance spigots or studs. You'll often see these in the gantries. And again, these are coordinated and often referred to as the tertiary control. And again, not everyone's favourite friend, but we have datum plates. And these give us what the relative values are to the track. So the relative from the running edge to the datum plate. They can be a little bit difficult in terms of maintaining them without having some kind of strategy in place, but regardless, it's what we often see on managed track position routes. I've done this diagram here just to try and illustrate the key concept of having a survey grid in place and kind of how it works. Again, this isn't to undermine the surveyors in the room, but just to try and illustrate it in as far as the use of GNSS or GPS type technology, where we can determine where the PGM survey control is. We can have GPS receivers, and then from there is software out there, Snake Grid, which post-process that information. So once you've got a survey grid, you're able to then extend that grid or transfer that grid from one area to another. And all this is available. All this technology isn't new, and it's been around for some time. It's really more a case about adopting it and understanding it. Hence why I've tried to illustrate it in this way. Survey and datum plate verification. Again, I've just tried to find a way of simplifying or explaining what the survey process is and how we use these survey controls. In this instance, we've got a track measuring device, and they simply shoot a laser to the TMG spigots. And because we know where those spigots are in space, we can then determine where that track position is. And likewise, we can take relative measurements to the datum plates. And in some ways, it's pretty kind of simple as that. Track design. Now, through alignment design, you often hear people talk about through alignment design, and the last time some while ago, I did a presentation, someone said to me, what is through alignment design? So I thought, well, I better explain briefly what it is. Conventional routes are often made up of many short elements. So it's not like a continuous track design. They're made up of very small elements. And these are sometimes even staging designs. But for managed track position, what you're looking for is a continuous design. And these tend to be more associated with major projects. Otherwise, trying to manage very small segments becomes very difficult, especially if you're doing work between them, where you're having to tie in and run in and out of various designs. So we've had a brief conversation in terms of what the survey control and the importance of the survey control and the survey design. And what this slide is illustrating is how the track renewal maps onto that survey control. The project designer can then determine what adjustments are required to install the track to the TAD, and they can complete their gauging and OLE analysis. And the track is then datum plated to the TAD position to enable the maintainer to realign it to its desired position. Now, of course, the maintainer can also use the TMG controls that we saw earlier on, but still, if they don't have that technology available, they can use the datum plates as well, just using relative offsets. There's also a case, and you might hear the term temporary or new TAD. So in this case, you can see the renewal site is slightly shorter, and you can see the green line going through the centre line there that represent the TAD. And this applies where it's not possible to reinstate the TAD, but the aim is to install the TAD on subsequent TAMPs. So if you're doing like staging type works, or for any reason that maintenance are going to realign the track at a future date. Again, clearance analysis must be done to the actual TAD, where the track should be, the temporary TAD, where you've temporarily left the track, and for any new TAD designs, where for whatever reason the designer may decide to permanently make the change, then he has to produce two designs. A design for the installation, what they're going to install the track to, and a design which ties into the original TAD that we hold on record. There's also consideration as well for the vertical deviation if you don't have managed track position. MTP can help monitor the gradual increase in the level during future maintenance tamping. This can eventually impact on gauging, OLE and structural loading on underbridges and UTXs by simply not knowing where the level of your track is. So we've very briefly described what managed track position is, the survey, the process once we've gathered all that data, what the design steps are. The question now is, how do we manage that? How do we manage that information? Well, we've got a track engineering form, and what the designer can do is that he can complete this form describing what work he's doing, whereabouts he's doing it, the extent of the site, and all these are simple pull-downs on an Excel spreadsheet that he fills out, given the extents of his horizontal and vertical design. We then review that information, and we capture any information such as any date and plate updates, and we give what we refer to as signed approval for that. We produce a response as part of the track engineering form, which we issue back to the designer. And if there's any amendments that we've found or we've had to make to his design, then these are highlighted in red. These forms, they feed into a TQN register, we call it. It's quite simple. It probably sounds more complicated than it is, but these feed into a register. And what that enables us to do is to produce various reports. So we can produce a renewals history report. Over years, we can see, well, what is the history of a particular location? What renewals have taken place? If it's high output, conventional plain line, we can build up that information. We can also highlight areas where we've had new TAD reports in areas, so we can start to see a pattern and manage the information going forward. We can also do analysis on the design checks by comparing where the design is and what changes they want to make. And we can also produce geometry reports, site information reports, and date and plate reports. So, for example, during the early grip stage, the renewals may want to know what's the condition of the track at the moment, where is it in relationship to the date and plate, and if the track is sitting higher than it should be, then at that stage they can arrange additional spoil wagons if they need them, and it's that early visibility which is so important. We even have instances where they have a renewal site and it could be starting within a transition, for example. And by having the track geometry reports, we'll be able to give that information to them early doors. Because you can build up a record over years of your track, and then you've got control and ownership of it. Right, that's enough of me babbling on. I'm going to hand over to Anthony. He's going to describe some of the tools that we use in terms of once we've got all this information, some of the digital tools that we're looking going forward for managing the information. Thank you.
Hello, everybody. This bit now would have been a demonstration of the app, but I wasn't brave enough to do that, so I decided to do screenshots. So what we're going to talk about is some of the things that Errol's speaking about, like the TEF form. I created those TEF forms, and they do contain a lot of Visual Basic. And Visual Basic is a problem because not everybody understands it, knows how to write it, and IT in Network Rail don't support it. And we identified that as a business risk, that if I left the company or something happened to me, a lot of the tools that we've got in place for managing this stuff is open to nobody can fix it, you can't maintain it. And so we decided to start looking at future technologies. And the future technologies I'm going to show you today is just one aspect of what we do, and that's the issuing of the digital data packs and what we're going to do going forward. Now, the data pack itself is usually requested to us via a track designer, and that includes the through alignment design, Form B, the survey control, PGMs and TMGs that I spoke about earlier, and chainage datums, which are basically a spreadsheet of information to tie you into the chainage of the geometry file and on site. The tool that I've created also has to account for change management. When we issue these files to a requester, a designer, quite often they're large files, they could be 8 miles long, and so more than one design house could actually ask for them. And so we then have 2 files that have equal capacity for being changed, and so we have to be able to manage the fact that both designers or one of the designers could change that file, re-establish their design into that file, issue it back to us, and we have to be able to manage that so that we can tell a designer that's got it out that there's been a change to it and it might affect what they're doing. Site information packs. These are also part of the tool that we're putting together, because these can also fit into the technologies. Errol briefly spoke about them before. The geometry file is a good one for us because when we send that one out, quite often we can send them to the guys scoping the works, and often they are starting their site in transitions and things like that, and that early stage can be found out from just requesting this information. So the through alignment design, survey control, all those things on the screen there now can sit in SharePoint document libraries. And while it's sitting in a SharePoint document library, it then becomes available to the Power Apps system, and Microsoft kindly allowed us to use their Power Apps to produce all sorts of things, Power Automate, Power BI, you've heard that today. And it leverages a few advantages, because you've got then the maintenance of these technologies is then, it's not just down to one person, it's not just down to me, it's across the board. Now these slides here and this sort of track is designed to break up the app a little bit. If I'd just showed you screenshots of the app, it would have been a bit confusing, so I'll put this in to show us where we are. And the start of the app is the client request app. So there's sort of 2 apps really. There's the client request and then what we do with it. And that's what it looks like. And all pictures, by the way, I took. So if you can see that, it looks good. And here you go. So the requester will fill their details in. And because they're prescribed what they can fill in, it's a consistent view. So we're always getting the same information. And they're not allowed to progress through the app until certain pieces of information that are actually required are filled out. And in this screenshot, I've filled out a request for data for Copenhagen, and in the future, what I intend to do is the engineering line reference, the ELR, they can only have certain miles and yards. I'm going to get it intelligent enough to be able to say, well, you can't pick that miles and yards, but it doesn't do that quite yet. And also, there's a tick box at the bottom there for additional site information packs if that's what you want. And once I filled that in, it's simple. It just creates an overview which is an email that is a formulated email. It's then consistent with a consistent subject header so that you can look for it in your emails and it'll be ordered in a consistent way. I've got a rich text box control there that you can then add any additional information to the request, and then it fires off as an email. But it also fires off as an update to a SharePoint list. So SharePoint lists will come into this quite often because SharePoint lists are sort of how it works. And then you get a success, well done, you've added your request. So we get the email, we also get an updated SharePoint list. So the next bit is then we review it. And this is the app that we use to review it. Now, this was there before this, I was asked to do this. So this is just a photo I took when I was working on the MSAT. So it's by accident that that's on there. And this is the SharePoint list that we've just updated. As a reviewer and as someone, I can go and select any one of these to go and have a look at. And in the example, I've selected the Copenhagen one that we've just put in. And it gives us an identical sort of area, but here we can amend any errors that might have been put into by the requester. And we can add new ones in because we might get the requests in through email or other means, and so we can actually generate them from this point going on. And then we start looking at the design sign out, and this is the bit where we're trying to manage the change control. Here, this is a gallery, they call them, and this is a list of the TAD files, they're ALG files. This is a list of the TAD files that pertain to the downfast on the CGJ1, and you simply select the file that you're interested in and then move to the next screen. Now, the bits where it says it's issued mean that it's issued to another designer, and bad TAD is, we're not going to deal with that here, but that's just a situation where the surveyed track and the TAD cannot be achieved, so we sort of manage that separately. So this is the area where we fill out the sign out bit. We fill out the red boxes. The red boxes are mandatory, and in the future that's going to be filled out automatically by the requesting data, but it's not at that point yet. Now, part of the program has to have a folder created, and so I've created, and I'm not really happy with this part of the app that much because there's 3 different ways of creating the folder, but I wanted to sort of constrain the folder naming because eventually you're going to have a lot of folders in SharePoint, and I wanted them to have a similar name structure. But this is a way of creating a name for the folder where parts of the ALG file will sit and the survey control going forward. And here's one where the file was already created, and so there's no need to create another one. We then go on to compiling the survey control. Now, the survey control area is just an area where we look at a SharePoint list of TMGs, we look at a SharePoint list of PGMs, and we query that SharePoint list for the area that we want. We needed it to be separate to the site extents because the site extents are usually too small. We normally need survey control outside of the site that we're dealing with. And so I had to create another query area. And this is what it looks like. And you run the query and you get your TMG list and you can check it in the viewer to see if that's exactly what you wanted and then run it again if it wasn't. And your PGMs is the same, and what this will do is it will send a request to Power Automate to generate a CSV file for each of those files. And the sort of final steps will be to issue the data. Now, this is the issue area where you've got an email, you've got the list of the files in the top corner there, and we tick those files. We can add other files. There's an attachment control in there, so you can add files from Form B files, for example, and other things if you need them. And then you press the Add To list, and what that does is it adds it to the folder and it also adds it to the email, but it also writes the email for you. The email's written with what attachments you've got, and it also details the design area that has signed it out concurrently with you. So they've got a point of contact in case they need to speak to them regarding the control of the alignment file. And then you just send it off. That then updates the list. Again, the requester list. And this is almost the last slide. It's just basically a collection of the lists that are created in SharePoint that enable this app to work. So you've got ALGs, so you've got your list of ALGs, the TMGs are all in there, PGMs, but there's the data packs, and also the ELR list at the bottom there, which is just the extents of the ELRs. And I suppose the point of that is that these tools are available to us, and they're the only things that we've got, and we're making a digital attempt to get, the problem with Excel macros and things in pencil cases into a more futuristic view. And that's me.